Here we have a map of the road system around Fort Kent, Maine. We have the public roads and the private woods roads here. Let's go ahead and check what coordinate system we're in. Right-click, Properties, Coordinate System tab of Data Frame Properties. We are looking at NAD, North American Datum 1983, UTM, Universal Transverse Mercator, Zone 19 North. There are 120 UTM zones. Each one of those has a central meridian off which you are referencing units in meters. So if you are right in the middle, you are going to be at an easting of 500,000. If you take one step to your right, if you're facing north, you're going to be at 500,001. So let's go ahead and carry on. This coordinate system has a geographic coordinate system that differs from one or more data sources in the map. We could be bad and say, don't ever warn me again, but then we would be getting ourselves in trouble if we tried to do any kind of a spatial analysis. So we want to use this coordinate system, but then we want to find out why we're getting this message. Roads WGS 1984. WGS 1984 is unprojected latitude and longitude coordinates, and that is the native language of the GPS system. So if we right-click here, we can go to the properties of this data layer and confirm that it is what it says, a layer in WGS, World Geodetic System 1984. There it is. So that is a problem for us. If we open the attribute table and try to calculate the attribute of length, then if we are trying to use the coordinate system of the data source, WGS 1984, it will not even let us calculate length because this is unprojected latitude and longitude coordinates. It will only let you give the coordinates of locations along the line. So cancel out of that. A very quick way to get a data set that is projected properly, if you have the data frame in the coordinate system you want already, right-click, Data, Export Data. And you want to use the same coordinate system as the data frame. Okay, the data frame is in UTMs, and now this new data layer will also be in UTMs. Here we go, NAD 1983, UTM 19 North, which is exactly the same as our data frame. That's a quick and easy way. Another way to do it is search for Tools, Reproject, and we have Project Data Management, which allows you to select an input, Roads WGS 1984, and it automatically loads in the coordinate system that comes with it. Tells it where to go, and the output coordinate system, we can select UTM Zone 19 North. If you don't have that in your favorites, you can go through Projected Coordinate Systems, UTM, NAD 1983, Zone 19 North, or any of these others here. NAD 1983, North American Datum, of course, only deals with the northern latitudes. You would need a southern datum or geographic reference point if you were going to work in the southerly UTM zones. So we have UTM Zone 19 North. Okay, so we are going from WGS 1984 to UTM Zone 19 North, and that has automatically loaded in a geographic transformation that will appropriately transform that data so that we can confidently go from the old coordinate system into the new. Okay, dun, 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 dun. Boom, close, and now we have a second new data set, Roads WGS 1984, Project 1. And now we can look at the properties again and see, yes, we are in NAD 1983, Zone 19 North. And now if we go to the properties, hit OK, we still get our error message. Now we know this is in 1984, but this one, or this is in UTMs and this one is in NAD 1984. So we'll hit yes for now. We can remove our original. Try that one more time. Properties, select OK, and now we don't get any error message because the coordinate system of the data and the coordinate system of the data frame are consistent. You are now ready to do spatial analyses between this layer and any other that is in the same projection.